Welcome, student. Myself, Mudesh Sharma from the Department of Mechanical Engineering. Today, I am going to discuss the new topic, shell mold, casting, cell molding. So, first of all, before introduce shell molding, where we use, I am going to discuss some common application of cell molding, where we can use cell mold casting application, like for making a mechanical parts that required high level of precision, or gear housing, slender head, and connecting rod. These common parts of an engine will be produced by the help of shell molding. Shell molding is also widely used in producing high precision of molding cores such as engine block, water jacket also. So this kind of molding is very efficient because it required minimum finishing operation. So now we discuss this process one by one. Our topic is shell molding and CO2 molding. Later, cell mold. After cell molding, we will discuss CO2 molding process. This is another process. Okay. Firstly, shell molding is a efficient and producing economical method for producing steel casting. The process was developed by the Herr Corning in Germany during World War II, and it's sometimes referred to as Corning shell process. This is a systematic diagram which shows shell molding, how to shell molding we use. This is a metallic pattern having a shape or desired shape, made one half from the carbon steel material, a pouring element provided in the pattern itself, which is shown in this figure. So, procedure for cell molding process. There are 5 to 6 basic steps we use for making shell molding. I discuss one by one. You can read by the help of this PPT. So, the first step is machine pattern with a good surface finish is heated about 230 to 260 degrees centigrade. Second step is sand resin mixture is dumped or blown over its surface. You can see in the given figure number 2. Next step is hot pattern melts and hardens the resin, which binds the sand grain with resin very closely and firmly with 20 to 30 seconds. And fourth step is a layer of sand resin mixture adhere to pattern. Thus, a shell of about 6 mm thickness is prepared. Rest of the sand grain are cleaned off. The thickness of the shell is controlled by the dwelling time, and it is also decide the required strength and rigidity to hold the weight of the molten metal. So you can see in this figure what I am saying to you. Now the next step is the shell mold with pattern is then heated and oven about 300 degrees centigrade for 15 to 60 centigrade for a curie time. Now pattern is ejected. You can see pattern is ejected by means of ejector pins mounted on the pattern. The shell thus form and constitute the one half of the mold. The second half is also prepared the similar way. Okay, so why this process? We can create shells like hollow cavity, or we create our part. I hope you will understand. These are the common advantages of shell molding. First is better surface finish, dimensional tolerance, reduced machining. Actually, this is good enough. Require less foundry space. Semi-skilled operator can handle the process easily because we don't require the highly qualified operator for this process. Shell can be stored or extended period of time. So I hope you will understand what are the common merit of the shell molding. Now we will discuss some disadvantages of the shell molding. Initially, the metric pattern, desired shape and size and weight range of casting is limited. This is another disadvantage. Processes generate noxious fume which create pollution, air pollution. And another disadvantage is dimensional limitation may be limited to some specific metal. Minimum thickness of the section that can be cast is 4 mm. This is another big disadvantage of this process. I hope you will understand by the help of this PPT video lecture. Now we are going to study CO2 molding process. Before discuss this, what is CO2 molding process? It is a sand molding process in which sodium silicate, that's formula is NO2O.X.SiO2, that is water glass is used as a binder 2 to 6% rather than clay, because in sand molding we use mostly clay. After the mold is prepared, CO2 gas is made to flow through the mold and the sand mixture. The hardness of the mold is prepared. The hardness of the mold is prepared CO2 gas is made to flow through the mold and the sand mixture hardness through a very rapid reaction, yielding a stiff gel. CO2 mold can be used producing a very smooth, intricate casting because the sand mix has a very high flowability, fill up the corners and integrate the counters. So I hope you will understand by the helping this video. These are some common steps involved making a CO2 molding. First step is sorry for disturbance. These are the common steps which will be discussed one by one. Suitable preparation of silica, sand, sodium silicate binder 3 to 5%, additive like aluminum oxide, molasses, etc. impart. The pattern displays a flat surface, drag boss enclosing it, parting sand sprinkled on the pattern surface. The drag box is filled. You can understand all the following steps by the helping some diagram which I am going to show you. This figure shows each and every step of this molding process one by one. I hope you will study very carefully. Okay, what are the common advantages of this process? First one is instantaneous strength development. Since process use relatively safe carbon dioxide gas, it does not present and sand disposal problem. Very little gas evolution during the pouring of metal. And other we can add, CO2 mold can be made without flask. Sands are free from flowing, therefore the ramming is eliminated or reduced. Tensile strength of the mold are higher than those of conventional molds. This permits the reduction of the mold weight and easier handling. The main disadvantage of this process: sand must be used immediately, poor collapsibility, there is a significant loss in the strength and hardness of the mold. Okay, I hope you will understand this process by the helping this video. If you have any issue and doubt, you can message me or mail me. Now, for better understanding of these process, I am going to add some animated video in this PPT video. Thank you so much.